Okay, so this is the step for the half-test test for the one population per person. Okay. So this is the first step. You need to state the random variable and the parameter inverse, okay, and state the null hypothesis and the alternative hypothesis, and also the level of significance. Okay. So you have to state here the level of significance. So there are how many? Three possibilities. Right? Left tail test. I mean less than or left tail test, greater than or right tail test, and not equal. Not equal, that means it's a two-tail test. Okay, so you can keep the is not as p equal to this p. I think it will be alpha. Right? I cannot see it. Let me see. Let me make it bigger. Okay, so now it's bigger. Look better. Right? Yeah. So and then the third step is you need to state and check the assumption of the hypothesis test. So first is the sample random sample of size n is taken, right? And then B, the condition for binomial distribution are satisfied. So so only two possibility, right? Success or fail. And the C, to determine the sampling distribution of P hat. So you need to show that NP greater than 5, greater than equal 5, and NQ also equal, greater than equal 5, where the Q is equal to 1 minus P. Okay. So if this requirement is true, then the sampling distribution of P hat is well approximated by the normal curve. Okay. And the third step, you need to find the sample statistic, the test statistic, and the p-value. Okay. So the sample proportion will be this one. P hat equal to x divided by n, or the number of success divided by the number of trial. Okay. And the statistic is in this formula. Okay. So you have P hat minus P divided by the square root of P times Q divided by N. Okay. Yeah, so you can, again, you can use the calculator or you can use the R program here. Okay. And also you can use the Excel that I put in MyOpenMath. Okay. So the conclusion like this. We reject the S naught or we fail to reject the S naught. Okay. The rule is if the p-value less than alpha, then we reject the S naught. Okay. If the p-value greater than alpha, then we fail to reject. Okay. And the interpretation or the conclusion about this is like this. Okay. So the conclusion of for hypothesis test is that you either have enough evidence to show that the S alternative is true, or you don't have enough evidence to show that the S alternative is true. Okay. So if you reject the null hypothesis, the conclusion will be you have enough evidence to show that SA is true. Okay. And the second conclusion, if we fail to reject the S naught, the conclusion will be we don't have enough evidence to show that S alternative is true. Okay. And this is the example. Okay. This is the example. So this is the example that we discussed yesterday, right? Okay. Yeah, you can read this by yourself. Okay? So you can see this is the step, right? Because this is 0.27%, we have to change to decimal number. So you got 0.0027. Okay? And you pick the alpha here 0.05. Yeah, so this is the first application for the hypothesis test. Okay, as you can see here, the example is maybe like from criminal justice, right? Because he's talking about uh, prisoner of crime, something like that. Okay, and you can find also, I think for this one is about breastfeeding. Maybe this is related to the social social work or social study, right? You know, you need to see what is the effect of the low income with the breastfeeding, right? Yeah, just another, this another example, and this is the example using the TI calculator, and this is the example from here, the example using the R, okay? Yeah, so the first application is for the sample population. I mean, hypothesis test for the population, the proportion test. And the second application is one sample test for the mean. Okay. So the first one is the sample test proportion for the proportion, and the second one is the sample test for the mean. Okay. So the step is similar. Okay. So just need to change the formula for how to find the test statistic. Okay. In this case, using the t distribution, we call it. Okay. And if you have to use the t distribution, you have to use this formula. Okay. So you need to divide by, we call it the degree of freedom. Okay. So if the sample size is n, so the degree of freedom is n minus 1. Okay. Yeah, you will see it from the problem that we discussed soon. Okay. So this is the step. What the hypothesis test for one population mean. Okay. So if it's less than, that means is Rattle test greater than Rattle test and not equal is two-tail test. Okay. Okay. So let's go to the problem. Okay. So this is the example. You can check it later. Okay. We're talking about the IQ score of famous people. So maybe it is related to what? Psychology, maybe, right? Yeah, problem in psychology, isn't right? Because you're talking about the IQ, something like that. Yeah, for this one, life expectancy. So maybe you can consider this as a sample in um, in the health, maybe, right? Healthcare or something like that. Okay, because she's talking about the life expectancy for a woman in Europe, something like that. Okay? Yeah, this is the data. Okay? And this is how to solve the problem using the calculator, and also you can use the programming. Okay? Yeah, so for the project, you will start with chapter 7, okay? And you can see there are some of the application and your major. Okay? Yeah, for this one, yeah, maybe you can consider this as a health problem, right? Because related to the carbon monoxide. And this one, yeah, this is related to health, I think. So if you major in nursing or something like that, you can use this one as example. FDA, FDA is talking about, yeah, I think this one also talking about health also, right? Health and environment, something like that, okay? For this one, I think this is experiment and physics, I think. Yeah, physics or engineering. For this one, yeah, I think this related to the health, right? The health science or nursing or something like that. Okay. But this one is, yeah, okay. So yeah, maybe it is related to the economy or business. And this one is about health again, right? Yeah, I think this is also related to the health again, right? Okay. And this is all of the reference that they use. What I mean, the textbook that the textbook use. Okay. So you can click this and in order to get the original article or journal. Okay. So yeah. So let's continue with the problem in MyOpenMath. Okay. Let's go to, I think last time we start with, I mean, we start from number 1 to number 7, I believe. Let me check it again. Oh, okay, not this one. So, should be this one. Okay. Yeah, apparently I use the your course. Okay, so I use section 1. Okay. Here's the example to solve the problem. Okay. You can see resume. So we did number 1, and number 1 is, yeah, last time we did this number 1. Right? You're looking for, you need to calculate the test statistic. Okay. For the for the proportion test. Okay. And this is the remember the formula that we had, the p hat, which is x divided by n, subtract with the p, right? The p is from the hypothesis. Okay. And then divide by the square root of the p, subtract with, I mean, multiply by the q, the q is 1 subtract with the p, right? And then divide by the n again. Yeah, I think this is, Yeah, so no, not this one, sorry. Yeah, this one, right? But I think somebody else working on this. Okay, so the original problem should be, this should be 89 over 116, right? So the original should be 116 minus 0.8, and then this one is 0.8. Yeah, actually you can write directly like you subtract 1 with 0.8, so you get 0.2, right? So you can also do it like that. Okay, so or you can just write the formula here like this. Okay, like you have to subtract from 1. You need to subtract 0.8 from 1. Okay, so got this one, and then this one should be the n again. So this one will be 1.6, right? Okay. So okay, so let's see. So what do you think? Maybe it's better if we continue for the next problem. Okay, so we discussed this last time. Okay, so I will continue with the next. I mean, the last problem that we discussed last time, so we can finish the whole chapter for today meeting. Okay? Yeah. So this is last time we did, right? Number 7. So let's number 8. Okay.
Excuse me, before you continue, can you do number 5? I like a lot of my problems I couldn't get the p-value on a lot of my problems.
Okay.
That's the same problem I had.
Okay. No problem. Okay. So let's go back to number 5. Okay. So for number 5, right? Yes, you always remember you have to be careful with this. Okay. This week for this problem, this is rattle test because it's greater than. Okay. So it depends on the head of the arrow. If the head on the arrow go to the right, that means it's rattle test. Okay. So this is the way to easy. I think this is the way to remember if it is a rattle test, rattle test. Okay. So you need to pay attention to the head of the arrow. If the head of the arrow pointing to the right side, so that means this problem is ratio test. Okay. Okay. So let me go back to, yeah. So this is the formula for the test. This is for the proportion, right? Okay. So this is to be p hat. P hat is the x divided by the n, and you subtract with the p divided by the square root of p times the q. In this case, the q is equal to 1 minus p, right? And then divided by the sample size again, okay, or the number of trial, okay. Okay, let's go to this problem. Okay, for this problem, this two-tailed test, okay. So I will show you the different way to answer this problem, okay. So for this one is greater than, okay. The way to find the test statistic the same, right? So the problem is only how to find the p-value, right? Okay. Okay, for this one is the one that I show you here is for this one is for two-tailed test. Okay. Two-tailed test is like this. I will show you the whiteboard. Okay. sorry, so this equal to 0, right? Okay. Let's see, this one is negative C, this one is C. So for left tilt test, you use this area on the left, okay? So this will be the p-value, the area on the left, okay? And this is the area on the right. So the p-value equal to, if you're looking for area on the left, it's equal to this, okay? Negative C. And actually this is also the same as the area on the right side. It is for x greater than C, because this is symmetric, right? Okay. So to find the two area, simply multiply by 2, right? Okay. So if you want to find what is the area for x less than negative C combined with the area for x greater than C. So this is the same as, oh sorry. So this is the same as 2 times the area on the left side, right? Okay. And in Excel, you can put norm S for the standard distribution, and negative C. And then you need to put true. Right? Okay. So this is the area on the left. So in order to get the area, so this one is related to this. Okay. And for this one, equal 2 times this. Okay. So also you can, if you want to find what is the area on the right, also you can use this one, right? The same as 1, subtract with the area on the right. Right? So in Excel, you can put 1 minus norm dot s dot this negative C and true. Okay. Yeah, so basically it's just like this. Okay. So so the C here can be okay. So if you go back to the problem, okay. Let me save this. If you go back to the problem, yeah, because this is okay. The problem that I have in the OpenMath here is two-tailed test because it's not equal. Okay, but this is a mini two-tailed test. So you can see here, this is the C, right? Because it's already negative here. Okay. So simply, so you got this one here is the test statistics for this So, you know, the cell for this statistic is C9, right? So just simply put this in the formula here, C9, and then times 2. You know, so the C9 is the area less than negative 1.6810 and so on. Okay? And because we need to have both area, remember the one in the whiteboard, because we need to have this area and this area, just so you simply multiply the area on the left by 2, right? So you got this one and this one because they are similar. Because they are similar, also they have the same area. Okay. So this is for the problem for the two-tailed test. Okay. So you have to be careful with your problem. Whether the left-tailed test or right-tailed test. Okay. For the left-tailed test, automatically you will get if you use this Excel, so automatically make sure this is negative, right? So you will get the p-value, okay, or the area on the left. Okay, one more thing. So this is the p-value. Okay. So what is the alpha here? What is the alpha? So the alpha is like this, right? It can be like a 0.01, can be 0.1, or alpha can be 0.05, right? So the alpha is the area that we reject the null hypothesis or fail to reject the null hypothesis. Okay. Okay. So let's see. Like put it like this. Okay. And so this is will be the alpha. Go like this. Okay. So if the p-value less than the alpha or the level of significance, so we if the p-value less than alpha, we reject the S naught, right? If the p-value greater than alpha, so the conclusion is we fail to reject. So only just two possibilities: reject or fail to reject. So you can see this is clear, right? So the p-value, so it's like the alpha is to show the rejection area, you call it, okay? So if the p-value less than alpha, or like the area on the left of the negative C, so because the p-value fall in this area, so we fail to reject, we reject the S naught. But if greater than alpha, for example, like the p-value right here, so we fail to reject the alpha. Okay, so yeah, this is all. I think it's just that you need to understand. Okay? All of the problem is related to only to this, in order to find what is the p-value. Okay. Let's see. Okay. Yeah, let me go back to the problem. So, yeah, so you want to solve your problem, so maybe you can discuss it here. Anyone? So you understand now?
Sorry, what did you say?
So you want to share your problem so we can discuss it? You can discuss it here.
Oh, I can, but I'm on my phone. I have it on my laptop.
Oh,
I
okay.
can't share screen.
Yeah. So what? Okay. Just let me know. What is this, the one here? Less than, greater than, or not equal?
Mine is less than.
Okay. For less than is for the less than. So for okay, this one is for two-tailed test, right? Okay. So this one is for two-tailed test. Okay. Like the problem that I have here. Okay. The problem that I have here, two-tailed test. Okay. So that's why I have to multiply by 2. Okay. So this is for the two-tailed test. And for the left-tailed test, you simply using this one here, and equal, and then oops, sorry, norm dot sds, okay, and then inside here click this guy, enter. So this for the left-tailed test or less than, okay. So if the hypothesis is less than, so you can just put like this, okay. This is for the left-tailed test. And for the problem in this Excel for right-tailed test, so for the left-tailed test, usually the number here is positive, okay. So usually the number that you got here is positive. Because if this is positive, so it's like the C like in this picture, okay. Oh, sorry, I didn't say that one. Okay. So if the C positive, I mean, if the number positive, so the number will be the number on the right side here, okay. So in order to find the number on the right side, so you can use by changing this negative C, so you got the area on the left side, which is the same as the area on the right side, right? Okay. So for the greater than or Rattle test, the C is usually is not usually. The C will be positive. Okay. So in order to find the p-value or the area on the right side of this, so you need to change this to negative C, and you get the area on the left, which is the same as the area on the right. Right? What you can do is you can subtract from one like this one. Okay. So you're looking for the area on the right side. If this is positive, right? So you can sorry, I think this one should be positive. So if you subtract 1 from the area on the left side of this, you got the area on the right side, right? Okay. So the same thing. Okay. So for this one, it's exactly you're looking for the area on the right side by subtracting 1 with the area on the left of this number or the C. Okay. So this area, right? Okay. Any question? Or you still confused?
Still confused.
Okay, I know. Okay. From where did you confuse? Which one did you confuse?
When you're speaking of, I just like your example. It's like a lot of stuff on the page. When you wrote things down, you can't really read it. But I get the fact that you're saying you gotta do 1 minus norm. I get that part. So like if I go in Excel and then put the 1 minus it, would that give me the answer?
Yes. If you put the Excel equal y minus the norm dot s dot this, and then sorry, I think this one should be positive. Okay. Sorry.
Okay.
Yeah. They got the judges. They got the lawyers. Also, you can find, and you're looking for the area on the right side. Also, you can use this one here. Right. So this one is like, okay, hold on, let me erase this one. Okay. Oh, sorry. So this one should be less than negative c. Okay. So you can see from this, and you're looking for the area on the right side, the same thing as you looking for the area on the right side by changing the c to negative, right? Okay. Here for the less than c, I mean less than minus c, this area, the same as this area because this is symmetric, right? Okay. So the easy, the most, I mean the Excel is looking for always the area on the left. Okay. Like for example, if this is negative c, so that means the Excel will looking for the area on the left side of negative c, or the p-value of the less than the p-value for the x less than negative c. Okay. So the p-value is represent the area of for the c less than for the negative c for the less than negative c. Okay, so this the value for the area less than of negative c, and this is the area for greater than c. It's the same as the area for less than negative c. So you're looking for the area on the right side of the area greater than c. So you can also using the same formula, but you have to make sure the c is negative. Okay. So I'm looking for, so this one will be the same as this one here, down here. Okay. Because down here is just looking for the area on the right side, right? So you can see here, the area on the right side here, the same as 1, right? The whole thing, subtract with the area on the left side of the C, right? Okay. So you subtract 1 with the area on the left side of the C, you get the area on the right side of the C. Okay. Still confused?
No, I got it.
Okay. So anyone? Yeah, maybe you can take the picture or I can send this to you. Okay. Okay, so yeah, so for number 5 here, for less than, so simply you type it like this. For total test, you multiply by 2. And for rattle test, usually the number here is negative. I mean positive. Okay, for rattle test. So you need to change to negative in order to get the area, which is the same as the area on the left side of the number, right? But it's I mean the same as the area on the negative number, right? The less than of negative number. Right? Okay. So did you get the correct answer now? You can try it. Okay, so can we move on to the next problem? Oh, no, this one. So this number 5, right? This number Yeah, so this is two-tailed test, right? So you can see here two-tailed test. So you're looking for the p-value. Because this is positive, right? So you have to subtract from 1 and multiply by 2 because you have two-tailed test, okay? Or you simply make it this is negative and you multiply by 2, so you got the same number, okay? Okay, so it's number 6, right? Okay. You can see for number 6. Yeah, probably number 6 also in this problem, I think so, and your problem is like two-tailed test, right? So if you have this, that's why you can subtract from 1 and multiply by 2, right? All you can do is change this to negative and multiply by 2, so you got the same number, right? Remember that I explained this uh, last time on Tuesday, okay? So you need to change this to negative. You need to change the P23 to negative in order to get the area on the left, right? And in order to get the area for two sides, so you need to multiply by 2. So this is for the two-tailed test, right? You need to find the area for both sides, the left one or the right one, right? Okay, okay, let me set the Google Sheet, okay, so you can use it, okay? So first, as you make sure you make sure like you copy the Excel, I mean the Google spreadsheet first before you change to your problem, okay? Let me share it to you. Let me share it with you, the Google Sheet, okay? Yeah, I will share the Google Sheet in the chat, okay? You can check the chat. Okay, so okay, where are we now? Okay, now we in a problem number 6, right? Yeah. Okay. You can see for number 6, I can do like a 2 times 1 subtract with the area on the left side of z, right? Or you can change to negative and then multiply by 2, so you will get the same number, right? Or the same answer. Okay? And in this case, the alpha is, I mean, the p-value greater than alpha. So we said that there's a fail to reject. Okay. So the conclusion is there is not sufficient sample evidence to support the, to support the claim. Right? Okay. Okay, let's go to the next problem. Okay, last time we did this one, right? Okay. Yeah, to get this one, you did divide 54 with 125, right? And to get this one, okay. And it said here, may not give head and tail equal probability. Right? So because it's not equal, this is not equal. So the hypothesis test is two-tailed test. Okay, so we have p equal to 0.5 and then p not equal to 0.5. Okay? And for looking for the test statistic, you need to do is using the same formula, right? Okay. For number 7, you need to use the same formula. Number 7. This is x divided by n, and for the z, x divided by n start with the p, right, divided by the square root of p times 1 minus 0.5, so the same as 0.5, right? Okay, and then divided by the n again. Okay, that's for number 8. Sorry, number 7. Let's go for number 8. Okay, we done also for number 8, right? Okay. Yeah, it's actually number 8 is just talking about, asking you about basic definition, something like that. Okay, so you can read it again the textbook and answer that problem. Okay. Okay, for this one, for question number 9. Okay, yeah, this is the same thing, right? So you have 79%. So the P is 0.79, and in this case is because yeah, for this one we assume that the test is letter test because it's P is less than 79, right? Okay. And for the C is easy for the C, right? So you just need to put the number there. Okay. Okay, so now we go to number 8, right? Oh, number 9. Okay, sorry. Yeah, number 9. Okay. Yeah, the same thing. So this one will be the X. Okay. So the X is 47 for my problem here. Forty-seven divided by the 47 divided by 62, right? 62. Oh, sorry, 62. Oh. And then the P 79, right? So this one is 79 and divided by the square root of 79. If you subtract 1 with 0.79, you got 1, 2, right? 0.21, right? Okay. Yeah, so this is the same thing as, I'll write it on here. So the same thing as I change this to 1 subtract with 0.79. Okay, you can see that got the same number, right? Okay. Yes. Okay. So that will be the answer for this problem. Okay, so if you want to write in 3 decimal, so you need to write like this. Oh, but this is wrong. Okay, let's see. I think I did something wrong. Okay, you know the problem here? I forgot to change this as to check it to, right? Okay. So you have to make sure this is also the same number as the one on the first term there. Yeah, so that's going to be 62. Okay. So the answer will be negative 0.617. Right? Negative 0.617. Okay, I'll continue with the next one. Okay, now we change the problem in, okay, this is the same thing, right? So still talking about the proportion, right? Okay. So for number 10, so for this problem, it is significantly more than, right? So more than that means it's a rattle test, okay, for this problem. Okay. Okay, so the statistic, the same thing. Okay, what do you have here? So you will have 32 divided by 74, right? So you have 32 divided by 74. Subtract by 0.3 because it's 3%, right? I mean 30%, right? And then divide by the square root of 0.3 times the Q. 1 subtract with 0.3, so you got 0.7, right? And this one should be divided by 74. Okay. So you got that number, and this is the p-value, right? Okay, because this is more than. Okay, let me see what is the problem that I have here. The problem that I have here is, yeah, more than, right? So because it's more than, so that means it's a rattle test, right? Okay. So because this is rattle test, so yeah, because it's rattle test, it should be this some changes. Okay, this is not correct one. Okay, they don't change the one here, but it's okay. Yeah, because it's a rattle test, right? So the same as you change this with the negative of the negative value of this one. Okay, enter. So this will be your answer for ratio test. So you can change this to negative, and you got the area on the left, which is the same as the area on the right side, right? Okay. So this will be answer for this problem. Or you can subtract from one, but make sure this is the same. Okay. Look at this. So you can put this equal sign. Yeah, if you want to use this, okay, you can put equal sign here. Equal sign, okay. But you need to keep this as positive number, okay. So you click this guy. You can see the same number, right? Okay. So you can change this number to negative, or you can use equal minus subtract with the area on the left side of this number, right? You got the same thing. You put the area on the right side of this number. Okay, so let me put this. Copy this. Oops, sorry. Yeah, copy, right? And then paste it here. Okay. And you need to round up to 4 decimal place. I think should be 65, right? And then the test statistic will be positive. Will be this guy. Okay. Oh, sorry, not this one. And you need to round up to 3 decimal. So this guy will be 6, right? And now you compare the alpha. The alpha is 0.01 and the p-value is 0.006. So that means the p-value is less than alpha, right? Because less than alpha, so the answer is reject the null hypothesis. Okay? So, and then the answer will be the third one. If fail to reject, the answer will be down here. But if reject, so the answer will be this one, right? So the sample data support the claim. Okay. Okay, so this number 10. Do you have any question? If you don't have any questions, so I will continue with number 11. Okay. Okay, so now the problem is changed from the proportion to the mean test. Okay. The p-value using the formula that I put in the Excel. Okay, so now you need to go to number 11, right? Okay. So the test statistic or the T equal to the mean subtract with the mu. I mean, you need to subtract the sample mean with the mean and the standard deviation. Right? Okay, so for the problem here, you subtract 38. No, this is the sample, right? Okay. Yeah, so this is the sample. So you need to subtract the mean with the mu, and then subtract, divide by the standard deviation, right? Okay. So The mean is 22.7. Subtract with the mu. $23.5. And then divide by the standard deviation, right? 4.18. 4.18. And then divide by the sample size. The sample size 38, right? Enter. So you can see this is negative because the the mean is less than the mu, right? So you can also see this is a Rattle test, okay? And you need to round up to decimal. So your answer will be negative 1.18, right? Negative 1.18, right? Yeah, negative 1.18, right? Okay, so you can continue with number 12. Yeah, the same thing. So, so number 12. Yeah, I put the 12 and 12b. Okay, so you can see for 12 is less than, and for the 12b is greater than. Okay, and also there is a possibility that there's a two-tailed test, so you need to multiply by 2. Okay, so okay, so you need to see whether is the problem here. Okay. So the problem here is Rattle test, right? Okay, so you can use the Rattle test. So you can use the 12b. Okay, so the test statistic here will be you need to put what is the mean, right? The mean is the m, so equal to 71.9. 71.9. Oops, minus 71.9 minus 67.9, right? $57.9. Oh, sorry. 67.9. Okay. And then the standard deviation is 16.7. So 16.7. And then the sample size is 11, right? Okay. 11. Enter. So now your problem is Rattle test. Sorry, Rattle test, right? So you can use for the three. We consider this one is use the t distribution. Okay, so the t distribution is you need to put like the degree of freedom. So instead of divide by n, so you divide by n minus 1 or the degree of freedom. Okay. So for the n equal to 15, the degree of freedom is 14. Okay. But in our problem here, the sample size is equal to 11, right? Or n equal to 11. So the degree of freedom will be equal to 10. Okay. So you have to make sure you need to change this to 10 because the degree of freedom, the sample size is 11, so the degree of freedom is n minus 1. So you have 11 subtract with 1, you got 10. Okay. So this is for the Rattle test. So you need to use if you use t distribution, you can use this one. T dot this dot rt and the number here, and then the degree of freedom. Okay. So let's copy the test statistic first, right? Put it here. How many decimal? 3 decimal. Will be that guy, okay. And then the p-value 4 decimal. 4 decimal. Okay. You need to copy this and then paste it here. And round up to 4 decimal, right? Okay. That's it, right? So now you can see the p-value greater than, it's like way greater than alpha, right? So you can see the p-value is 0.2227 and the alpha is 0.005, right? So the p-value greater than alpha, okay? Because it's greater than alpha, so the answer will be, the decision will be fail to reject, okay? So fail to reject, I mean that there is not sufficient sample evidence to support the claim, okay? Okay. Yeah, so you can continue with number 13. Number 13. So the test statistic will be the mean subtract with the mu and divide by the standard deviation, right? Okay. So in this case, the mean is 83.5. 83.5. Subtract with the mu, 84.8. And then divide by the standard deviation, 14.1. And divide by the sample size, 57, right? 57. Enter. Okay, so now you can see the problem here is left tail test, right? Okay, because it's less than. Okay. So for left tail test, you just simply using the same as the formula that we have in the Google Spreadsheet or Excel. And you have to be careful, you need to change this one, right? This is the degree of freedom, which is the sample size subtract with 1. Okay. So the sample size that we have here is 57. So the degree of freedom will be 56, right? So this one will be 56. Right? Okay. So first you need to copy this one first. Sit here. And round up to 3 decimal place. And then you need to copy the p value. Paste it here. Round up to 4 decimal place. Okay. So you can see again the p value is greater than alpha, right? Okay. And because greater than alpha, so fail to reject. And the answer will be the last one. There is not sufficient sample evidence to support the claim. Okay, let's go to the next problem. Yeah, for this one, you have the data that you can use to prove, the hypothesis reject or fail to reject. Okay. So first thing first to do is you need to copy this data, right? And then put in your Google spreadsheet or Excel for number 14. Yeah, so copy and paste it. Okay, apparently the data is longer than the data in the problem, right? Okay, so maybe you can cancel. Maybe you can put it. Yeah, you can insert row below or row above, right? And do it again. Do it again. Okay. Okay, I think it's enough. Right? So now you can put it here, right click, paste it. Right? Okay. So the last data is it's 8.9. Okay, now. So, oops, sorry. So you can see here, the data is from A9 to A13, right? So you have to make sure the mean will be from A9 to A13. Okay, so you need to change this to A13. The same thing for the standard deviation. So you need to change from A9 to A13. Okay. So now the test statistic will be the mean start with the mu and divided by the standard deviation and divided by the sample size, right? Okay. So this is the mean. This is the standard deviation, okay, and then this one is the sample size. The sample size in this case is 1, 2, 3, 4, 5, right? 5, okay. So you need to change this to 5. Okay, what else you need to change? You need to change this one, right? So the mu here is 65.3. So you need to change this to 65.3. Basically just flip the number, right? Okay, 65.3. So this is the test statistics, and you can see also for this problem is not equal, so that means total test. But for our problem here, it's ratio test. Okay. So yeah, so our problem here is ratio test. Okay. So you need to change this to positive, and the degree of freedom is because you have 5, so the degree of freedom is 4 here. Okay. And you have ratio test, so you need to change this to RT. Okay. RT means ratio test. Okay. Okay, so this is the test statistics. Put it here. Round up to 3 decimal number. And the p-value will be this one. Round up to 4 decimal place. Like that. Right? Now you can compare the alpha with the p-value. So you can see the p-value is less than alpha, right? Okay. And because less than, so reject the null hypothesis. And the answer will be the third one. Yeah. The sample data support the claim. Okay, so the next one will be 15. Yeah, okay. Yeah, I think the same thing. Right? So you need to copy all of this data, right? And then paste this to the Excel for number 15. Okay. So put it here, right click, and then paste it. Right? Does that work? I think that works, right? And the last data is 59.5, right? So you need to make sure this is 59.5. Okay, right there. Okay. So you have extra data here, so you can highlight it, and then you highlight it, and then press the delete button. Okay. Now you can see the data is from row 8 to row 16. Okay, so that means this one you need to change to 16. This also 16. This also 16. Okay. Yeah, 16, 16, 16. Okay. Now you can see here, all of we already have the formula. I mean, we already have the number here. We pick from, because this one is the mean, this is the standard deviation, this is the sample size, right? Now you need to change this one here. Okay? This is the mu, right? So the mu will be 62.9. 62.9. Enter. So this will be the test statistics. And for the p-value, you have to be careful, okay? What the problem is greater than, okay? So for greater than, okay, for this one is for two-tailed test because the problem in the Excel yet not equal, so two-tailed test, okay? So for your problem here, maybe it's better you create this is for two-tailed test, okay? For this one. This for two-tailed test. For the rattle test, for our problem here, for our rattle test, you need to use t dot distribution rattle test, okay? And then click this guy, right? Comma, because you have 45, because the sample 45, so the degree of freedom will be 44, okay? So the same thing as you want to change this, if this is the problem with two-tailed test, so you need to change that one with 44, okay? So this is for the rattle test. Okay? Math, clear. Okay, so let's copy the statistics first, and then put it here, 3 decimal 7, and the p-value for ratio test, right? You need to put it here. So for 4 decimal, that means this one will be, the 4 become 49 become 50, right? So this one become 1. And you can see again, this one is like the p-value greater than alpha. So the conclusion will be fail to reject. And the conclusion will be this one. There is not enough sufficient sample evidence to support the claim. Yeah. So that's it for number 15. We still have 15 minutes, I think. Yeah, we can continue. So I just say significantly different than 3. So there is significantly different than 3. That means is just two-tailed test, okay? So looking for the one that's not equal to 3. So so the answer will be this one. And the answer is, the test is a two-tailed test. Because it's significantly different than 3. So it will be this one. So the test is two-tailed test, and the test statistic will be uh, yeah, you need to subtract the sample mean with the mu, and then divide by the standard deviation and the sample size, right? The square root of the sample size. So let's go to number 16. The problem the same two-tailed test, right? Is not equal to 3. Right? Okay, so the formula here will be the mean is 3 or 300, and then the mu is, sorry, the mean is 302 and the mu is 3, right? So this is 302, 3.02, and this one is 3.0. And then the standard deviation is 0.04. 0.04. And the sample size 25. And yeah, so I already put it here. Okay, so for the two-tailed test, automatically you got this number here. Okay, so like I already put the formula. Okay. So this is for two-tailed test. Okay, as you can see here, Excel for two-tailed test, right? And then this one is Excel for left-tailed test. Okay. Oh yeah, you have to make sure. Okay, sorry. This one is a two-tailed test. Okay. And the sample size is 25. So the degree of freedom will be 24, right? Okay, so this one should be 24. This is for two-tailed test. You can see, make sure this is positive, okay? This is why we put absolute value here, okay? So because you're looking for two-tailed test, so the answer will be this one. But if you're looking for the left-tailed test, the answer will be this one. But make sure that this is, you have to change this to the correct degree of freedom. This is 24, okay? And the same thing for this one. Yeah, this one is like the left-tailed test also, okay? No, I said this one for rattle test. Okay? So you can subtract from 1 or you can change it with RT. Okay? Okay, so because it's two-tailed test, so our answer will be this one, right? Okay. Oops, sorry. You need to round up to the decimal, so the answer will be 0.02, right? For the p-value. Okay. And for the test statistics, you got 2.5. And if you compare the p-value 0.02 with alpha 0.01, so that means the p-value greater than alpha, right? So the answer is fail to reject. Okay, so the next question. If you know how to this is equal to this one, okay, then the test is two-tailed test, right? Easy, okay. Yeah, you should put this in the beginning of this problem when we have the starting with the what do you call it? The hypothesis test for the mean, right? Okay. Yeah, so in this case, you already have the test statistics, so you just need to find what is the p-value, right? And the answer is left-tailed test. So simply for number 18. Yeah, so already put the formula here. Okay. So you can have for left-tailed test, you just need to change this to what do you have here? The z-score here is negative 0.75, right? Negative 0.75. So negative 0.75. Yeah, we should put this in the beginning, I think. So you can see here, this is Rattle Test, this is Rattle Test, this is Total Test, right? Okay. So our problem here is Rattle Test. Okay, so the answer will be this one. Rattle Test. Put it here. And for decimal, so the answer will be this one, right? Okay. Okay, so that's easy because just need to put this one. And Rattle Test, so you pick the for the Rattle Test. Okay. Okay. So if your claim is the null hypothesis and you reject the null, okay. If your claim is the null hypothesis, right, and you reject the null hypothesis, then your conclusion will be what? Remember, what is the answer? Anyone? What is the answer for this one? Yeah, the answer is easy. So, do you know what is the answer? Anyone? Okay, let me ask someone here. Okay, let me ask Miss Kasunapert. Are you still here?
Sir?
Yeah, so can you answer this? If your claim is in the null hypothesis and you reject the null hypothesis, then your conclusion would be what? Maybe this one, right? There is
Yes, sir.
there is sufficient evidence to warrant the rejection of the original claim. Is that right?
Yes, sir.
Okay. Because the claim is null hypothesis and then we reject, so the answer will be this one, right? Okay. Yes, you're right. Okay, good job. Okay. Okay, I think this one will be the last one, the next one. And easy, I think, right? Okay. Less than 14% of the internet users pay bill online. In which of the following graphs does the shaded region best represent the critical region? Okay, this one. The first one, the second one, or the third one? Anyone? Okay, let's see. Let's point to Miss Azaria. Are you here? Miss Azaria?
Would it be the third one, maybe? Critical. Oh no, I think it's the first one.
The first one, because it's what? Less than, right? Okay. Yes, you're right. Okay. Okay, so yeah, I think that's all for chapter 7. Okay, so I will post the